Okay, let's just begin for today. Just give me 1 more minute. Today is going to be about casting and converting types. So it's going to be interesting. Almost there. Okay, now I just need one more thing and we are done. So today is about casting and converting data types. Yeah, well, welcome. Uh, Welcome to one more stream about doing exercises on .NET 5 basic exercises. Now we are moving forward to the basic from the basic, and we are to begin with some more complex data. I hope you have enjoyed the previous videos, and let me know if you have any question. Remember that you are able to get the examples from GitHub, and you are able to test them by yourself at GitHub slash /tbarriguete. I'm going to write it up at the chat. And well, this morning is going to be very interesting. I just need to validate that the address is the correct one. But today we are going to talk about to do some exercises about the casting and converting. That's the way of how you perform the change of how a variable of how if you have a value of a variable into a variable, you are going to use that value into another variable or pass it through another variable. So you are going to be able to use that information, but with a variable that has more or has less limit of information. I mean, for example, there are several type. Well, first we are going to create. First, we are going to create our own structure. So I'm here in terminal. Net exercises. Exercise 1. MD. Cast convert. Okay, now 4. Today is the 4th session. 04. Okay, I'm going to close this one. Now I'm going to create a new console application. So .NET clear screen, .NET new console. Remember that this is going to create our project. We don't have nothing and we have a project, a program, and some folders. Okay, so we have here hello world, and after that casting and convert examples. Now what are we going to do here? Okay. Well, sometimes you have information. This happens more on numbers. You have information on a specific value, like an integer or a double or a float, and you need to use it on another variable of another type, because that type there's a reason that, because one type you have a way. Yeah, I'm trying to explain, but for example, here in .NET we have the int value, var integer variable equals 0, right? And we have a float integer float variable equals 0, and we have a double variable equals 0. We have a small int. Okay, we have int 16. Int 16. It's the same as a short variable equals 0. And we have also another ones that is like int 64. On the other hand, also we have uint unsigned integer variable equals 0, and we have the same ones for the other ones. We have float. Remember that we are able to do this. Float, double, and short. And all of them store numbers. Float also, don't forget to use decimal. Decimal is our best friend to use for money numbers. Decimal variable. And the same one for you, decimal. Okay, there is no unsigned for decimal. Okay, so we have numbers, and the main difference is the following. We have the short store less numbers than the int. The int has more values. It's able to store more values. For this description, I'm going to look C#. data types in short. These are integral numeric types. We have the also we have here the S byte. This one is for sign byte. Sign byte variable. Also, and after that, well, this is the one, and as an unsigned, we have the byte variable. We have the short, the u short, int, u int. Also, above we have long variable, and the same one for the u int, u long variable. Okay, now with this information we have different types, different numbers that we are able to keep. For example, the sign byte, it has, this one is a bit number, so that this means that we have 1 2 3 4 1 2 3 4, we have 4 positions, we have 8 positions, and this is not a big number, and you have to remember that the first one, this bit, is the sign bit, so you don't have all these numbers, this 8-bit number. Seven 7-bit number, 7 bits number with sign. Okay, so this one is the sign, and we only have this one, so it's a number between less 128 to 127. That's the max, the max value, negative or positive. For the short, also for byte, you have a bits number without sign. So this means that we have 1 2 3 4 1 2 3 4, all of them. So it goes from 0 to 256 55. Yeah. And then we have the int. Int is a 32 bits integer number with sign. Long is a 64 bits long number sign. So the integer goes to 2 billions, 2.147 billions, less 2.147 billions, up to 2.147 billions, and long goes up to, well, comes from less, it's a hard number, it's a hard number to read. We have millions, billions, trillions, quadrillions. quintillions, 9 quintillions, from less 9 quintillions up to 9 quintillions. And well, basically we have these ones. Now, what we have for the other ones, here we have decimal positions on all of the three. The main difference is that float and double use the numbers as in a non-exactly way to do the things. I mean, a float and a double, if you increase the number too much, there are some times that you will get a value that is not going to be the value that you set up. What I mean with this is if you place a float variable, you will have, I don't know, 9 millions or 10 millions. And this one, this 10 millions, is going to be represented not as 10 millions. It's going to be represented on another way, like I'm going to look for that word. Uh, um, you have to power a number. Yeah, you are going to have a representation to the power of n. I mean, you have, if you have 9 millions in decimal, you are going to always have 9 millions, that representation. But for floats and for double, you may have situations where you have, instead of 9 millions, you are going to have 10 to the power of, no, yeah, 10 to the power, 9 to the power of, no, just 9 times 10 to the power of 10, right? So that's a that that that's a different representation. That's a different representation, because instead of having 9 millions, and this one, you are going to, in float equals 9 times 10 to the power of, and we have 1, 2, 3, 4, 5, 6, 6 times. We are going to have this representation. The issue is what happens if I plus 1 to this number. Okay, we don't have that number. We have this one. So instead of only doing this, the machine is going to look for a way to add this, and if that one is going to be converted to something like 0.000001. Okay, and you're going to have this number, but this is a more complex number, and by complex I don't mean that it's more exactly. It has a weird way to represent it, and at certain time we are going to lose this number. So the main point here is, if you are going to use numbers for amounts, for money, for measures that need to stay exact as the same way as you place them on your application, use decimal. Decimal is the variable that you need to keep precision. Float and double are good to use, but consider that if you are storing numbers or doing some doing some operations, sometimes you could get a non-exactly value, and this more happens with there's a type of error or a type of bug with the name of the zero of the machine. That means that a machine has a number that is not zero, but if you add or if you remove that amount from another number, that that number is going to be the same as if you added or removed zero. There won't be any change because the numbers are having a ground representation. For example, if to this one I also say, okay, I'm going to less 0.001, right? So this kind of transformation is going to be more complex because you will need another 3 more positions, and these ones are going to be 999 because you are removing 0.001. And when you get the final, maybe you will lose on this multiplication some value. This it's a similar case as if you are if you have numbers that are not that their division is not exactly the same, the an exact value. I mean, maybe 10 between 3, you will get 3.3333, and that's not an exact value. But well, this is what we have on a computer, on a program. So that getting back to the point, use always decimal to store numbers, exact numbers for money, measures, or something else. Use this one. The main difference between decimal, float, and double is the precision, and the main difference between decimal, float, double, and int, long, short is that decimal, float, and double have they have decimal positions. You are able to not only have 1 or 5, you are going to be able to handle 1.5, 1.10, 6.9, etc. And these ones are only integers. You only have the exact value without decimals. So these are the types of variables that we have. Okay, now we need to create the example with this. Okay, I began this streaming with the word with the title casting and converting. We are going to converting is also known as casting. You may use it as a synonym, but there's a difference of how you do a cast and how you do a convert, because you have implicit and explicit ways to do the casting and the converting. Some implicit casting cases happens automatically and you won't have any trouble with that. You won't lose any information. But when there are another cases when you have to do explicit casting, an explicit casting must be performed by you. You have to place that code. and this explicit the explicit casting is not automatically, because the compiler is going to let you know that you have issues with that conversion of variables, and by issue it means you are going to lose information. Okay, so because you have that condition, you have the compiler throws out an error or a word, an error, and you have to check that, correct it, and then place the right value for your the right conversion for the variables that you are using, and your value is going to maybe is going to lose information. We are going to see this right now. So we have an integer, uh, integer variable. Mhm. An integer variable equals 10, and then we have double variable, and double variable, and double variable equals integer variable. Mhm. Then console print right line, and this is going to be values of integer variable. um Integer variable is going to be integer variable, and double variable, double variable. Okay, now I'm going to place comments here. First, I want to clear screen.net build. I'm going to build this, and you are going to see that everything is okay with this one. Okay, it says that you float doesn't exist. Okay, how do I know that these are the integral numeric types? I'm going to give you the answer here. This is the documentation for the integral numeric parts, and this one, integral numeric types, C#, and floating point numeric types. Okay, we don't have unsigned. Floatable, yeah. The floating point numerical types doesn't have a unsigned type. So the only ones that use the unsigned is the integral numeric types byte, uint, ulong, and ushort. Okay, that was my bad. So first, that's why we got these errors here. So now .NET build. We are going to see what we have here. We have several warnings about this variable are not being used. Correct compilation is correct. And that's it. Okay, so what I'm going to do, I'm going to comment all of this, and I'm going to use the integer value and the double variable. Okay, yeah, have this and we have this, and then we have integer variable, double variable, and this is the conversion or the casting. The double variable and integer variable. For this case, I prefer to call it cast because you are casting from this value to this value. And the conversion, I always use it when you use the method convert. You're going to see it after this example. Now, clear screen, .NET run. Okay, and we have casting and convert examples values of integer variable 10, double variable 10. This is quite simple, just equals, and that's it. Even if they are different types of variables. Why that this is the automatic way? This is the implicit way, because you have a value that, and that one is int, and a tuple is able to handle more values than the integer, so there's no issue. The compiler sees this conversion and says, hey, okay, I'm able to cast this value to this type of variable, and I'm this is not going to lose information, so it's okay, and it lets you continue. But what happens if we perform the to the other way? If we say, okay, this one is implicit conversion, but what happens if we have backwards? Well, oh, I just saw a comment on the chat that says, which one should we use for financial application development? For financial application development is the you must use decimal. Decimal is the one that has more precision. Double and float are going to get you on trouble. That's it. Mm, okay. And now, what else do we have here? We're going to change it. So instead of integer variable, I'm going to use double variable. Then I'm going to set up this one, double variable. Okay. Now we are doing backwards. We have a double variable value. We have a value into double variable, and then we are going to change it to pass it to integer variable. We have the value of 10. And this is what happens when we have that .NET run. For this case, we have a conversion that throws an error, and it says error 266. You are not able to convert implicitly a double into int. There's an explicit conversion. Try if review if you need another conversion. For this case, we have the value of 10 stored on our double variable, and we have then the integer variable. Double stores more values than integer, so in the case that you have a big number of that, you have 10.5, the integer is not able to handle this point, that the values that are after the point. So for this case, you have to you have to let the compiler knows, okay, I know that I'm going to convert this and I'm aware that I could lose information about this. So it doesn't matter. Please convert this, cast, and this is the way of how you do your cast. You have the double variable, and before the double variable, you place parentheses and the type of the variable that you want to convert. So for this case is int, and it says, okay, this is a double variable. I know I want to store it at this integer variable. I know, and then before sending me the value, cast it or convert it to an integer variable, and this integer variable, and this is going to convert, this is going to do something like 10.5. Okay, 10.5. It's going to be converted to 10. You lose information here, you lose this information because you don't have the information after the decimal point. Integer only stores integer values. So this explicit conversion is letting the compiler know, okay, um, you have you are going to lose I'm going to lose information and I'm aware of it. Okay, so what's going to happen here? We have this case, no, save .NET run, and there you go. Okay, casting and compare variables. Casting and compare examples. Values of integer variable is 10 and double variable 10.5. Now we didn't get any error or any warning because this explicit casting is the one that is advising the compiler. Hey, I know that this is going to lose values. It doesn't matter, just compare them. We are aware of this. And well, this is the way of how you have to see that. Um, there is another way to view the problems on Visual Studio Code. For example, you also are able to do .NET. We have this tab here. We have the terminal, we have problems, and I remember that problems is another one that appears here. View. This one, problems, Control Shift M. So clear screen. .NET run. So if you have any issue also, you also are able to click on problems. Okay, this is not working on. .NET build. Let's see if this gets aware of the problems. No, it doesn't. Okay, well, the idea was that. The idea was to convert this and to see the problems here, but well, I don't see it. Sometimes I don't understand why we don't have more a better way to do this. Control Shift M. No. Filter. This is the debug console, the output. No problems have detected. And we have the library. Okay, the pending changes. And C sharp. Yeah, it's installed. Okay, well, I don't know. This tool is not working as expected, but it will be here. Okay, well, let's continue. We have another things. Let's say we have converted a double. We have performed a casting, explicit conversion, explicit cast conversion. And here you're going to have the variable int. The 0.5 information is lost. Okay, and now we are going to use our long, and the same happens with another types of value that store more values than the original. So we have the long variable, and long variable equals 25, and then if you try to set up this integer to an integer variable, now we got the problems. You see here? Let's see. Long variable equals no. Integer variable equals long variable. Okay, it doesn't detect the lack of casting, but it detects the lack of semicolon. See? Okay, well, I never expect nothing from you, and you always disappoint me. Console, right line, values of console, right line, integer variable. Integer variable, double variable, double variable. No. Long variable. Okay. There you go. I'm going to comment this, and then we have the same value as previously. Same situation. .NET run, and we are going to get an error. You are not able to convert implicitly from long to int. So what we have to do here is do my casting, and after this .NET run. And we have this. Casting and compare types, values of integer variable 25, double variable. Long variable 25. Okay, now we are getting the correct one. Yeah, long variable 21, 25. This error is related to the declaration of our double variable and the assignation to a value, and that one is not being used. So right now it's not a problem, but you have not just to declare variables and keep them unused. We have changed that. You have always to use them. If not, you are going to have a memory issue. Now, there's these variables. Usually, you have a way to know their max value. I'm not sure about long variable dot equals long variable long variable dot max. I saw that. Long max value and long dot min value. These are related to the data type. So long max value and also you have long min value. For example, we are going to use long min value. And then let's see what happens here. Using the min value or max value. This is the min value that long is able to store. .NET run. And here you have integer variable. This is our example from here, and then we have the long variable. Long variable equals min value, and that means the 9 quintillions, less 9 quintillions. It's the minimum value. And what happens when you try to store this one as an integer variable? You get 0 because you don't have enough to handle this value. So when this is trying to convert this, something happens that it's not able to handle all of this. Let's see the other example. What happens if we use backwards? Min value instead of min value. Now we are going to use max value. Okay. For the negative way, it was 0 the result. .NET run. And now, as you see here, for the max value that we have 9 quintillions positive, the value that you got for an integer is less 1. This will be integer is 32 bits, so this one will be something like 1 4 32 8 12 16 20 20 24 28 30, 32. This is the number that is storing here, and the long variable comes from another thing. It comes from a bigger number than this. So that's the main concern about converting and casting. You have to be aware of what value you have on your variable because there must be a reason that you are using a specific data type for your variable, and sometimes you have to convert between types, but not all the time is the right thing that you have to do, because you have to remember, if you have a big variable and you want to convert it to a variable that stores less, you are going to have issues. You are going to lose information, and you are going to have several bugs, and you will say, hey, but my value is converting here. Yeah, but if you have stored a big value, then you are going to have issues with this. Okay, this is the case of this. If you have a long variable with the its minimum value, you're going to get back a 0 as an integer, and if you place the max value, you are going to get less 1. Okay, so that thing is it's going to be a really headache for that. So now there is um, another way to store a number, to write up a number. Right now we have used this notation. I'm going to use the example with the 9 millions. For example, long variable equals 9 millions. 1, 2, 3, 1, 2, 3. And then I'm going to remove this one, these values. Now I'm going to set the same one. Okay. Now let's see. Also, I'm going to comment this one. This is not being used. .NET clear screen. .NET run. Now what we have here, we have the integer value 9 millions and the long variable 9 millions. Okay. Now there's a special way. When you have a value that has big numbers and those numbers are static, you are able to grind them up since the beginning of your development. You are able to do you are able to use a special notation for this. So instead of using this one, this maybe comes another developer and see, hey, this is a 900,000. And this is because the developer didn't watch zero, zero, yeah, the zero, and he lost a position. So if you want to avoid that cases, you're able to use an underscore between the numbers. If you use the underscore, you have to place underscore each 3 positions of the numbers. So for this you're going to get the 9 millions. But this notation is easier to see because you will see, okay, it's 3 zeros and then a 9. Okay, yeah, it's a 9 millions. So you are going to be .NET run. You're going to see that this code works exactly the same way as the other one. But the main difference is that you are placing here, okay, I have a 9 million number, and this is easier than just watching 9, 1, 2, 3, 1, 2, 3, and even it's harder to try. It's harder to write down this one, right? And now, well, yeah, you have a better way to see this one on screen when you are developing the application. But what happens on the application if I want that my users see this value on a more friendly way? Okay, for that one, this way to concat the information into the string, you are able to use styles. So you have just to grab up, for example, where's the long value? And 0 and colon and 0, clear screen, .NET run. And for this case, if you place here n0 colon n0, it means that okay, you have this variable and you are going to apply this special type, a special format. So we have n0 and this changes, well, less one doesn't have any change, but long variable has 9 comma 223 comma 372 comma 0 0 3 0 36. This way is way a better way and the easier way to watch this than having this number in this way. I remember that you are able to use another like money, currency. I'm not sure. Well, this one worked on .NET Framework. I'm not sure if this one uh, is able to be used in .NET Core. Oh yeah, .NET Core uses the same. If you place colon C, C is for currency, an uppercase currency, uppercase C, C uppercase, and you have this with cents. You have this amount with cents, only the last two, so that you don't have to convert, because here you don't have the last two numbers after the point. So this is a good way to do this. A better way to just handle the information and place it in a friendly way to see it. And now also we have previously I talked about that there's a casting and converting, and casting is the same as converting. Cast is a conversion, but why is the difference here for these two? Here you've been done a cast, so with this notation, this parenthesis, you cast the value, and this cast means that you are converting the variable to another variable type. So why do you have a difference between a cast and convert? Talking about words, well, this is because console, I don't remember if it's console, no, system, this namespace has another library with the name convert. This is an abstract class. This class is able to convert between different types. For example, to int. Okay. Here when you need to convert, you have to int 16, int 32, int 64. Okay, and to uint 16, uint 32, uint 64. You don't have, sometimes you don't know, or you don't remember, a short is 16 or is 64. It's a dumb question, but maybe it's valid. Or a byte is a 16, I'm not sure. Well, for that case, we have this explanation that I sent you here, the floating point and the integral numeric types. Here you may find the values that this type of variable is able to keep. So with this one, you will see, okay, I have an integer, and an integer is 32 signed 32-bit integer, okay, and it's the same as system.int32, and then you are able to do your conversion in the right way. So you have to write this way. Instead of doing, I'm going to use using convert instead of cast, and this is more like a word than anything, but this is the automatic way, and this is like if you are using operators to perform this operation. But what happens if we use the convert? Well, we have the long variable converting values. Okay, now instead of having this, we are going to use system has that convert dot to int 32. My integer is at 32, and then it allows you to receive an object and from a provider, a pool, char, s byte, byte, short, u int, long, u long. Long is the one that we are going to use, but also it's able to receive a string, a date time. So we have here this ones. I'm going to place something different so that we are going to know that we have information here, the converting variables. So clear screen.net run. Yep, so converting types, we have the integer variable 25, long variable. As you see, and as you remember in the beginning of this streaming, if we place integer equals long variable, we had a value that was not able to be converted because we are losing information, and we needed to cast it so that there won't be any error on the compiler. .NET build. So here you have, and this completion is correct. The same happens with convert. Convert is the explicit way to perform a conversion, and the compilers read that as, okay, I know that I'm going to lose information. I'm not taking a risk here. It doesn't matter. Just let it go, and it let it go. So this is the other way that you are able to convert the number. And for sometimes you will get some weird cases because I'm going to show you something really strange. Long variable, and then I'm going to use my double variable. And when we have 25.9, okay. 25.9 screen, 25.9. Where's my long variable? No, top variable. 25.9. double variable. Let's see. I'm going to place this. No, I don't know. I don't need. .NET run. Now what happens? I have 25.9 and I'm converting to int. Instead of having 25, the conversion brings me 26 instead of 25.9. So these are cases that you will say, hey, come on, what's going on here? And this is a special situation. Let's figure out. Screen .NET run 25.6. We still got 26. What's happening here? Well, this is doing a round. This is rounding the number, and that's why you need to be aware of this type of situations. You will say that we were talking about, and you will thought, oh, okay, you convert this, so you just remove this value, delete it, and pass it directly to my integer. But not always, because for this case, for the convert, you have the situation that you are, well, that the machine is rounding your number, rounding up. I don't remember if that happens with 20.5. I remember that the rule is 0.5 and up goes up, 0.4 and less go less. .NET run. Let's see. Yeah, 0.5. This is going to be awkward if 0.4 also works the same way. I hope not. Yeah. No, it's rounding in the normal way. 0.5 goes up, 0.4 and less goes down. We have you have to be very careful here, because you just think that this is going to be cut off, and it's not the case. It's not the way of how you think that this is going to work. It's the way of how is created to work with this. So you have to be very aware of these cases. And for this case of the rounded numbers, the main difference between cast and convert is that one. I'm going to copy these ones, only these two, the latest two. Remember, this is converts usually rounds the number. Now let's try with the cast. Testing round on cast. Double variable int double variable. Okay, let's see, clear screen, run. Okay, I'm going to place the same. Test cast run. We have the test cast run, and we have here 25, 25.5, and 25, 25 point. The cast is just streaming this number, and the convert is not. The convert is rounding the number. Yeah, we have 25.9, we got 25, 25.4, 25. The difference is here, the big difference is here. The double variable 25.9, 26, and 25.5, 26. This is a big issue, and you have to be aware of this kind of situations because you will have some special numbers for that. So the rule for rounding a number in C# is it's the following way. It always rounds down if the decimal part is less than the midpoint 0.5. So that if you have, for example, 7.49, it's going to be round to 7 because it's 0.49. And it always rounds up if the decimal part is more than the midpoint. I mean, it's 0.5 or above, then it's going to round up. Let's see. Okay, so how how could we control? Well, I'm not sure that you are able to control the rounding here with this cast, with this convert, but at some point there's a special situation. 25 goes up. Okay, and if I got here 26, let's see. 26.5. Yeah, there's a special situation with this rounding way because here you have 26 because we have 25.9, and when we got 25.5 it went up to 26. But if I place 26.5, it doesn't move to 26, 27. It keeps up with 26. So there's a special rule with rounding in C# because okay, it always rounds down if the decimal part is less than the midpoint. I mean, if the number is 0.5 is less than 0.5, 10.49 or 10.49, 10.4, it rounds down. It always rounds up if the decimal part is more than 0.5. Okay, so right now I'm not describing the case when the number is 0.5. It's above 0.5. So 0.51, 0.50000001, it's going to round up. Now what happens with the 0.5? The 0.5 has a special rule. I don't know why it's considered this way. If the decimal part, it will round up only in the case that the decimal part is 0.5, only 0.5, not 0.500001 or 0.51. If exactly the number is 0.5, for example 11.5, and the non-decimal part is odd, is going to round up. But if the non-decimal part is even, and the decimal part is 0.5, then is going to round round down. What's this case we're talking about? Okay, let's see. These are the kind of special cases that you will have to have in mind. We have 25.5 and then 26.5, 27.5, and 28.5. Okay, so this is a console write line. That's the important part. What really matters right now. Okay, clear screen. What we got here? Okay, this is the case. We have 25.5, 26.5, 27.5, 28.5. What happens? Well, we have 26 because this is even, because this is just give me a second. Okay, because this is odd, 25 and 27, and the non-decimal part is odd. Okay, 25, 27, they are odd, and the decimal part is 0.5. You are being rounding up. Decimal part is 0.5 and non-decimal part is odd. Then it rounds up to the next number, 26. But what happened with the other number? What's this? Right? Okay, the situation is this: if the non-decimal part is even, 26, 28, and you have a 0.5, your number is going to be round down. This is weird, and these are special cases, but when you are presented to these kind of special cases, you have to remember these weird rules. But well, this is the case. Just please remember this special rule of the round up and the round down. And well, maths in C# work this way. We are not able to change that, but we are able to round explicitly a number by our own method or our own definition. So what what happens after this? Then you maybe will say, hey, okay, I want to take control of my rounding rules so that if I got a number and I have to convert it using the convert method, I need to be sure that before the conversion, this number is going to be rounded. In a special case, I mean, maybe you always want to round up. If your number has a decimal, just one, it must round up. And if your number has decimal, it doesn't matter, you are going always to round down. Or maybe you have to round up when you are at 0.6, but you must round down if your number is 0.59, right? Just something less than 0.6. So for this case, we are going to have, well, you are able to use the math class. What kind of sorcery is this? Yeah, I know, I know. It's really, this is very weird. But for that cases, in cases that you need to control the rounds, you are able to round using the math library. The math library is something that comes on the system package. I remember that it comes on system package. You just have to write up math, yeah, point, and then you're able to use round. And this one is going to take a double, and then it's going to say how many digits you are going to use. But let's see. So you are able to say how many digits and the midpoint rounding mode. This is the important part for us because you are able to, okay, math for let's continue 25.0, no, 0.1. How many digits? Okay, we don't want digits here. You're able to say, okay, I want a midpoint rounding dot away to 0 or to even. So what are we going to do here? We are going to do the following. 25.5 midpoint rounding. Okay, the midpoint rounding is 0.5. Okay, so away from 0, okay, and I'm going to write up directly the value. Right line, now, well, just the other day we just got the 4 and switch and on the loops. Let's try this. 4, okay, while double variable less than, no, we're going to be 25.4. Okay, double variable 0.1 while double variable less than 25.6. No, 7. Okay. And what are we going to write? Console write line integer no double value double variable, and we are going to use then is rounded. We are going to use this method. Well, instead of this, we are going to use double variable. I know. Okay, then double variable plus 0.1. What's going on here? Semicolon. Yeah. Net screen.net run. Okay, now what we have here? Double bar. I forgot the $sign. Yeah. Come on. .net run. So you have this one and midpoint away from 0. Okay, so this is going to be 25.4 is 25 and 25.5 is 26. 25.5 is 26. Now let's try it this way. 26. Okay, and then if double variable equals 25.7, then I'm going to change double variable equals 26.4. Okay, we're going to move forward from 25 to 6. Let run. Double interval. Okay, yeah, the validation is this one, double equals. You have to do the examples by yourself because that way you're going to be able to test it. Well, what kind of sorcery is this? Gosh. Yeah, we have situations like this. And this is not okay, but well. 26.4. I have to write it down this way. 25.70003. Man, that's really weird. Come on. These are the special cases that you have with doubles. As you see, we only increase by 0.1, but it's not only a 0.1. The double is using something else, something weird. And each time that you add a 0.1, instead of only adding a 0.1, is adding a 0.100000001. Yeah, and then we come here, and this behaves really different because we have 0.10001, 0.20001, 003, 001, and then it adds another numbers here. So this is the situation, HDSD Gabriel. This is the situation why you don't have to use a double or a float for financial applications, because from nowhere you are going to get cents for your customer and you are going to have this strange situation. So I'm going to change it to this because of that. If you don't do these exercises by yourself, you are not going to get it and get the wrong way. Ah, come on, this is really weird. 26.4. Okay, that's not what I was expected. Double variable is less, and double variable less than 26. Ah, come on. Okay, it was in a loop, infinite loop. If you got an infinite loop, you are able to just press Control C, and you end your application. And this is why you have here this one. Clear screen.net run. And here we have the double value. Here, remember, here we are controlling the way of how the rounding is taking place. 0.4 is 25.4 is 25 rounded, 25.5 is 26, 25.6 is 26, 26.4 is 26, and 26.5 is 27. It rounds up. If you have if you have 0.5 or more away from 0, and the other one is dot to even. Let's try this. Screen.net run. So if you use the to even, then if you have the 0.5 and uneven, it goes down. If you have a 0.5 and odd number, it goes up. So better is to use away from 0, and this is going to round in the normal way. .net run in the normal way that you learned from school. Yeah, that's better. That's much better. And well, finally, we have the conversion from any type to a string, and the conversion from a binary object to a string, and parsing data. That ones are I'm going to explain that ones in the next streaming, but I hope that you enjoyed this one. We got really strange situations with the double. These kind of situations are similar on float. You are not going to be able to see these kind of errors if you don't try to do something, if you don't try to do a special program by yourself or testing. Uh, and even with simple situations, you will get these kind of errors. So, I mean, it is a special situation for this. I encourage you to take the examples. I'm going to upload the version um, of this code from today, and we'll see you next week with more examples. Okay, have a nice day. Bye.